All right, number one. So the question is, you're given this function, a set of ordered pairs, and you want to know, is this a one-to-one function? All right, so remember, I'm going to do that here. This is part A. So you know this is going to be a one-to-one function. Let's look at the mapping. Y, x. When y is 4, x is negative 2. When y is 6, x is 3. When y is 5, x is 4. When y is 0, x is 1. So is this a one-to-one function? The answer is yes. Yes, because for each y coordinate, there's only one x coordinate. Yes, since for each y coordinate, there is only one x coordinate. So remember the definition of a function. So I'm just going to remind you what the definition of one-to-one function is. I meant the one-to-one function. So remember, a one-to-one function is a function in which for each y coordinate, there's only one x coordinate. So that's how you determine that. Now, if it is, find the inverse. Well, that's what we just talked about in those previous lessons, right? So to find the inverse, remember, it comes from the idea that you used when finding the function, the inverse function algebraically. So let me go ahead and find those steps just to remind you. And it looks like I can't locate those steps, but I can't locate those steps. But remember, when finding the inverse, remember one of the steps was to interchange the coordinates. So if you're going to find the inverse, see this is f, so you're going to say f inverse equals, and you're going to do this. Negative 2, 4 becomes 4, negative 2. So you just interchange the coordinates. 3, 6 becomes 6, 3. 4, 5 becomes 5, 4. And then 1, 0 becomes 0, 1. But keep in mind, though, you got to say f inverse. All right, so if this is f, then this is f inverse. All right, so that's number one. Okay, let's go to the next one. All right, now remember the algebraic. So let me go ahead and actually find that page. I kind of lost that page about the algebraic part. So now they want you to do this algebraically. So it's very similar. Remember those steps? It's very similar to those steps you used in previous lessons. So let me see where those steps are real quick. Here we go. All right. Remember step 1. Replace f of x with y, or g of x, whatever it is. It could be g of x, h of x, but whatever this is, you're going to replace it with y. Then you interchange the coordinates, then you solve for y, and then you replace y with the notation inverse. All right, so let's look at this one. Step 1. Replace h of x with y. So y equals x cubed plus 12, right? Step 2. Interchange the coordinates. X equals y cubed plus 12. Step 3. Solve for y. So you get y by itself. So I'm going to go ahead and rewrite this over. So you're going to subtract 12 from both sides. So now you get x minus 12 equals y cubed. And remember, you're getting y by itself. So right now I'm cubing y. The opposite of cubing is to cube root. So I'm going to take the cube root of both sides. And the cube root undo each other. So you get y equals the cube root of x minus 12. And there's your inverse. So step 4. Remember, this is h of x. You can say h inverse of x equal the cube root of x minus 12. All right. Part B. Now remember the square root. So remember if you mentally look at the graph of this, remember the square root. I'm sorry, the quadratic. Excuse me, quadratic. It looks something like this. All right, and you know it's not one-to-one, right? So you got to restrict. So notice that this little part here is what we're going to restrict it to. See, it says x is greater than or equal to 5. So we're going to get rid of this little part here. So that's, since, remember, this is not one-to-one, so we have to restrict the domain. So that was talked about in another lesson. All right, so let's do this algebraically. Step 1, replace g of x with y. So y equals x squared minus 15. Step 2, interchange the variables. So x equals y squared minus 15. Step 3 is to get y by itself. Solve for y. So we go ahead and rewrite this over. So I'm going to add 15 to both sides. So I get x plus 15 equals y squared. Then you're going to take the square root of both sides. Now remember, don't do that plus or minus here because your domain was restricted. So you're only going to be looking at the positive square root. So y equals, these undo each other. So y equals the square root of x plus 15. And there's your inverse. So step 4, you're going to say g inverse of x, because remember this is g of x. So you can say g inverse of x equals this right here, the square root of x plus 15. All right, C. All right, let's look at C. So in letter C, you have this rational function. All right, now listen carefully how we're going to do this. So you got to be careful. So step 1, replace h of x with y. So y equals 6 divided by x minus 2. Now, so that part's easy. Step 2 is easy as well. Remember, step 2, interchange the variables. X equals 6 divided by y minus 2. All right, now, this is where you're going to be careful. So I'm going to go ahead and rewrite this over. All right, so I want to get y by itself, right? So you see you have this equation that has a fraction. So what I'm going to do, I'm going to rewrite this over like this. What I'm going to do is I'm going to multiply both sides by that LCD. So my LCD here is y minus 2. So I'm going to multiply both sides by y minus 2, just like this. So remember, one of the things you got to do is you got to clear those fractions. So you're clearing the fractions. So these y minus 2's divide out, and you get x. I'm going to rewrite it like this. X times y minus 2 equals 6. X times y minus 2 equals 6. Now distribute, get rid of the parentheses. You get xy minus 2x equals 6. Now be careful. Remember, step 3, remember, is to solve for y. So I got to get y by itself, right? So I'm going to isolate this term. So I got to add 2x to both sides now. So I'm going to add 2x to both sides. So these cancel out. So you get x, y equal 6 plus 2x. And now to get y by itself, you're going to divide by x, because right now I'm multiplying by x. So you can divide by x. X is divide out here. So you get y equal 6 plus 2x divided by x, and you're done. You got y by itself, so that's your inverse. So h of x equals this means, step 4, h inverse of x equals this, 6 plus 2x divided by x. So there is a problem on your worksheet that looks like this, so just make sure you go through those steps. So at some point, you're going to clear the fractions, so you're going to multiply both sides by the LCD. That's what you see here. All right, and then that's it. So that was C. Now look at D. Okay, so f of x equals the square root of x plus 4. So just kind of remind you what that looks like. So the square root of x plus 4 in terms of transformations. So you see how the plus 4 is under the square root? So that's going to be a horizontal translation to the left. So here's what that looks like. Just to kind of remind you real quick. So 1, 2, 3, 4. So it looks like this. So this is the function, the square root of x plus 4. Kind of makes sense because if you do a t-table, when x is 0, I get 0 plus 4 is 4, and the square root of 4 is 2. So that's here. Okay? That's 0, 2 right here. When x is, let's say, negative 4, I get the square root of negative 4 plus 4. So that's the square root of 0, which is 0. So you get negative 4 is 0, which is this right here. So just continue using that t-table and you'll get these points here. So it looks like this. Okay, but, and then you also notice this passes the horizontal line test, right? So it's a one-to-one function. But you want to find the inverse. So remember, if it's a one-to-one function, it has an inverse. So step 1, replace f of x with y. So y equals the square root of x plus 4. Step 2, is to interchange the variables. So x equals the square root of y plus 4. That was step 2. Step 3 is to get y by itself. Okay, I'm going to rewrite this over. Okay, now listen carefully to this. Okay, so I'm trying to get y by itself, right? So you see the square root? So I got to get rid of that square root symbol. So one way to get rid of that square root symbol is to raise both sides to a power equal to the index. So if I'm square rooting y plus 4, the opposite of square rooting is to square both sides. And so I get x squared equals, and then the square and the square root undo each other, so you have y plus 4. And now I can easily get y by itself. So I'm going to subtract 4 from both sides, and so I get x squared minus 4 is equal to y. So x squared minus 4 is equal to y. And there's the inverse. So if this is f of x, then f inverse of x will equal x squared minus 4. Now, remember, x squared minus 4 looks like this. So you just got to remember some things here. This is f inverse. So x squared minus 4, I'm going to put y equal x squared minus 4 looks like this. All right, and so notice that this is not a one-to-one function. So you'll also see this. So when I go back here, the domain of this, when you look at the graph, domain is from -4 to infinity. So x is greater than or equal to -4. And your range is from 0 to infinity. So y, your range, is greater than or equal to 0. So remember, this right here, the domain of this is greater than or equal to -4. The range is y is greater than or equal to 0. When you find the inverse, the domain becomes the range becomes the domain. And the reason is because of the interchanging right here. Everything is interchanged. X becomes y, y becomes x. Domain becomes range, range becomes domain. So the domain of this will be x is greater than or equal to 0. So x, see that the range becomes a domain. So x is greater than or equal to 0, and the range, you're going to take the domain. So y will be greater than or equal to -4. And so now when you look at this in terms of this is what you're graphing now. So let me go ahead and rewrite this part here. This I'm rewriting here. So x is greater than or equal to 0, y is greater than or equal to -4. So when you look at this, when I'm only graphing the part of the graph that's greater than or equal to 0, right? So when I do a t-table, when x is 0, 0 squared minus 4 is -4. When x is 1, 1 squared is 1, 1 minus 4 is -3. When x is 2, because I'm only using positive numbers, when x is 2, 2 squared is 4, 4 minus 4 is 0. So what's happening is this. You get 0, -4, 1, -3, 2, 0, and you get this part here. And so notice this follows this right here. So that one was a difficult one right here. That one was a difficult one. Most students, when they get to this point, see, now remember, all I had was this. So when they get to that point, they'll say f inverse is this. Well, that's not quite this. It's not quite this because this is a parabola. So you got to talk about the restrictions. So that's why we had to go back here and we had to indicate, well, the domain of this is this and the range is this. And so now the domain becomes the range and the range becomes the domain. And now this has this graph. So that one was hard. That was a difficult one. But that should give you enough information to somehow get through worksheet number 3. The first part's easy right here. It is right here that you got to be careful. All right, so when you do D right here, use this example to help you. Just follow those steps when doing D. Okay? All right, so we are past our time limit.